Okay, converting these numbers into scientific notation, and you've got to have 3 significant digits. So you start on the left, and you highlight the first 3 numbers, and then you figure out, okay, you're going to have to write this in scientific. The decimal, if it's not shown, is at the end, and I need to move it into such a position that it makes a number between 1 but not more than 10. To move it all the way over to get between the 6 and the first number. So essentially it's going to be 6.00, because that would be 3 significant digits. But how many places did I move it? So you can start by counting 3, 6, 9, 12, 15, 18, 19, 20, 21. So 6.00 by 10 to the 21 is the correct answer for number 1. Number 2, you want to keep 3 significant digits. So it will be 5.47. Places you move the decimal, you have to move it from end to between the 5 and the 4, which is 5 places. So 5.47 by 10 to the 5th. For 3, you got to keep 3 significant digits. So 350, but the next one is 7. It's going to round it up, so it's going to be 3.51 by 10 to the how many places? So 369. To get the decimal from the end to the position between the 3 and the 5. Now number 4 is going from a small number into scientific. 3 significant digits would be 463. The decimal is going to have to end between the 4 and the 6. How many places is that going to be? Start counting. So 3, 6, 9, 10, 11, 12. The number's very, very small. Therefore, you write it in scientific, it's going to be a negative exponent. 4.63 by 10 to the negative 12. For number 5, at 906, the 7 would round it up, so it's going to become 907. So 9.07. The decimal moved a grand total 4 places to the right, so 10 to the negative 4. For number 6, 790, the 6 would round the 0 up to a 1, so 7.91. How many places? 3, 6, 8. 10 to the 8 is 10 times 10, 8 times. Number 7, 479 are the first 3. The 0 can't round it up, so it's going to stay 4.79. The number's very small. How many places did it get moved? So 1, 2, 3, 4, 5, 6, 7 places. It's a negative exponent because it's a small number. Number 8, 3 significant digits. So 980. So it's going to become 9.80. And that's 3, 6, 9, 12, 15, 18, 21, 24, 27, 31. 9.80 by 10 to the 31. Number 9, 497. The 0 doesn't round it up. So 3, 6, 7, 8. 4.97 by 10 to the negative 8. And then the last one, number 10, we're going to keep 465. So 4.65 is proper scientific. Every number on this page is less than 10, but greater than 1. And that will be 10 to the negative 4 for proper scientific. Now the second question, I want you to go backwards from standard form into regular notation. But you have to keep only 2 significant digits. So 3, 4 is going to be your numbers. 3, 4, so basically it's 3.4 times 10 to the 7. So you're going to move the decimal once to get to the end of the 4. So it becomes 34, and then 6 zeros to finish off your scientific. Double check. That's the same number. 5.04 by 10 to the negative 4. I'm going to keep the 5 and the 0 with 2 significant digits. I'll rewrite it. So 5.0 by 10 to the negative 4. I'm going to move it one place to get it in front of the 5. So I'm going to move it one place here. It's going to become 5, 0. And then I have to add 3 more zeros to hold the place. Double check. That's 5 times 10 to the negative 4. Notice it's 5, 0, not just a 5 at the end. I want to keep 2 significant digits. 4.0689. So 4.0, the 6 will round it up, so it's going to become 4.1 by 10 to the 8. So to convert that, you're going to take the decimal place, move it 1 to the right. 41 is one place. Then you need to add 7 zeros to use up all of your factors of 10. So 410 million is the answer. 1.05, 1, 5, 2 significant digits. So the 5 is going to round it up. You're going to have 1.1 by 10 to the 9 before you do any converting to regular form. So one place, we'll move it to 11, followed by 8 zeros. And if you want to, it's 1.1 billion. 6.4523. 6.4, the 5 would round it up to 6.5, and it's times 10 to the negative 5th. So you move the decimal one place to the left, would take you to 0.65. Then you have to add 4 zeros to get back to standard form. So you would have 0.000065, and maybe even a 0 in the front to hold the place. But notice there's 2 significant digits, 2 significant digits, 2 significant digits, 2 significant digits, and of course 2. And the last one be 8.2 rounded by 10 to the second. So it'll be 82 be one factor of 10, 820 for 2 factors of 10. And that completes the questions on that page.